and welcome to the Math League YouTube channel. The following video was recorded by one of our staff members live at one of our contests.
Okay. Hello, I'm back. So I'm going to talk about number 7 on the round that you just took. So we want to find the center, basically the center of the ellipse defined by this equation, right? So before we begin, I'm first going to say a disclaimer. The solution that I'm about to explain is not our official solution, and none of our problems will require the use of calculus. They're able to be solved with other methods, but I'm going to show you one that involves calculus. So we have this ellipse, right? Actually, let's just forget about ellipses for now. Let's look at circles. Let's look at circles, right? So if you have a circle, right, and let's say the circle's equation is x minus 3 squared plus y minus 2 squared is equal to 9, let's say, right? Then where would you say the center is? Well, this is just the standard equation of a circle, so the center is at 3, 2, right? Now, if I told you to ignore the right-hand side, forget about this 9, and say, take a look at the left-hand side, where is this quantity minimized? Well, this is just the sum of 2 squares, right? So this quantity is minimized when both squares are 0. That is when x equals 0. Sorry, not x equals 0. When x minus 3 equals 0, which is when x equals 3. And y minus 2 is 0, or y is equal to 2. And so now you see that the center of the circle is exactly where this expression is minimized, right? We can do the same thing here. The center of this ellipse is exactly where this thing is minimized. So we can employ calculus to help us do that. So let's erase all that for now. So then how do we find the minimum? Well, if you want to find the minimum in a calculus problem, you've done that many times before if you've taken calculus, right? It's one of the probably the second or third thing you do after you figure out how to do derivatives is you just set the derivatives equal to 0. So if you take the derivative of this with respect to x, what do we get? We get 6x. Let's see, partial f partial x, right, is equal to 6x plus 2y. That doesn't have an x in it, so we ignore that, plus 8, right? And that is the derivative with respect to x. Taking the derivative with respect to y, right? Looking only at y's here, right? This doesn't have a y, so we ignore that. 2xy, if you take the derivative of that, that's just 2x. And if we take the derivative of this, 2y squared, that'll become 4y. And 6y, that'll become plus 6. And since the 8x doesn't have y in it, we also ignore that. So these are two derivatives, right? And there is probably a local minimum or local maximum where this equals 0, right? And so now what do we have? We have two linear equations. And so now basically we know that the center has to be where these two linear equations are satisfied. Now it's just solving linear equations, right? You've done that many times before. I'll just give you the answer that x is equal to -1 and y is equal to -1. And that satisfies this. So this is where this expression is minimized. And at the same time, we figured out that the place where this is minimized is also where the center of the ellipse is. So center of the ellipse is at -1, comma -1. And the sum of this, -1 plus -1, is -2. So this is just basically another way to solve this problem that if you don't really know how to do it originally, it's just another way if you've done calculus before. So yeah.
Hi everybody, this is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.